Confidence. Alright, let's start with reducing fractions. There is a procedure. Let's say we had 10 over 15. We want to reduce that to its simplest form.
Use 5.
It's 5.
I want to reduce it. That's 2. And 3.
Alright, that's the answer, but how'd you get there?
Because you have to use 5.
Angelina?
Find like the problem multiple.
Yeah, you're going to have to find some term that will divide both of these terms evenly, and it has to be a whole number. It can't be like 2.5 or something. It has to be a whole number. In this case, we divide both of them by 5. We're going to get 2 over 3. Now, is this in its simplest form?
Yeah.
Right, because there's nothing that goes into 2 and 3 evenly, therefore this is in its simplest.
Find both into divisible by both numbers.
Find that whole number. Take this out. We don't need it anymore. So what we have to do is find some whole number that divides evenly into the numerator and the denominator. It has to be the same number. You can't use 2 for the numerator and 3 for the denominator. I've seen people do that. It's got to be the same number, the same term. I just want to do a couple of caveats here. 2. If you have an even in your numerator and an even in your denominator, you can always divide by 2. Okay, I'm going to pick a couple of numbers here. This is even, this is even. Now I know there's a larger value than 2 that will work for both of these, but just to illustrate the problem, if I divide both of these by 2, what do I get?
6 over 12.
6 over 12. Well, both of these are still even. So I can divide by 2 again. I'm going to get 3 over 6. Okay. In this case, I still can divide both of these by
3.
That's in simplest form. If you're ever stuck and you don't know what to use and then both terms are even, always start with 2 and work your way down. It'll make that ratio a lot smaller, it'll be easier to work with. So, anytime you have an answer that has an even in the numerator and the denominator, start dividing by 2 if you can't find any other value. Does that make sense?
Yes.
All right. Let's go through something else here. All right. We're going to just say always use 2 if the terms are even, right? What about 3? What type of number would 3 go into?
6.
Yeah. It would go into 6. What else would it go into? 9. What else? What else?
15.
What else?
18. 21.
Let's go in order. Let's not jump past it. 21. 24. Go ahead, David.
No, 27.
Thank you. David likes to take 5 steps ahead of everybody just to show he's in the lead. All right, how about 4? 8. Well, you're not going to do 1, right?
No.
You're going to try 4 first. 8.
12.
16. 24. 28.
Okay. How about 5?
10.
'" All right, let's look at this. It's oscillating between 0 and 5 in this last digit, isn't it? Therefore, if it ends in 0 or ends in 5 is divisible by 5. How about 6? 12,
18,
18,
24,
24,
30,
All right, I want to look at something here. Let's look at 3 and 6. They both have 12. What else?
24.
Both have 18.
They
They both have 24. So what could you conclude from that?
You divide it by 3 or 6.
Yeah, odds are, if you can divide it by 6, probably it's going to be divisible by 3. If it's divisible by 3, it's probably divisible by 6 also. By going to the higher value, you'll have less reducing to do. Conversely, if it's divisible by 6, it's also divisible by 3. It works either way. All right, how about 7?
14, 21, 28,
32.
35,
5.
42, 56.
All right, 56. And 8? Now, do you think 8 and 4 are going to be a lot alike?
Yeah.
Yeah, because 4 is a multiple of 8. So let's start here with 8. We're going to get what? 16, 24,
32,
32, 40, 48, 56,
64, 72.
All right, now let's look at 8 and 4. They both have 16. They both have 24.
32.
They both have 32. Would be over here, right? Is there a pattern? It's taking every other one. 8 will take every other one. Does everybody know what I mean by that? What I mean by that? Here you got 12, you go to 16, it has 16, it misses 20, but it takes 24. 4 and 4, if you're adding 4, add another 4, that's the 8. So that works out. How about 9? 18, 27, 36, 45, 54, 63, 72, 81. What about 3, 6, and 9? 3 has 18, right?
Yep.
You all have 18.
6 of 18.
You all have 24. No, not 24. 36, right?
No, never mind. 6 has 36.
Yeah, I'm looking for 3.
Oh, 36.
Yeah, 3 can go into 36 too.
Oh, wait a minute, we got another here? What is this? 30, 33, 36. All right, we didn't go far enough. Sort of get the idea. So 3 and 6 and 9 are almost interchangeable. Let's take 3 over 27. One trick is on usually on textbook problems. Try the numerator directly into the denominator. Right. Does 3 go into 27?
Yes.
All right, so if we divide both of these by 3, we're going to get 1 over 9. How about this one? 24 over 36. Well, we look at this, they're both even. We know 2 will work. All right, well, what else will work?
6, 3.
4 works here, 4 works here. How about 8? 8 works here, not here.
Not there.
How about 4, 8? How about 12?
Yes.
Oh, 12 will work, right? 16? No. All right. Probably 12 is about the highest we can go. So let's divide this by 12 and divide this by 12. We're going to get 2 over 3. Well, 2 is prime, right? And 2 doesn't go to 3, so we know that's in its lowest, simplest form. Get ready for this.
That's 1 over 6.
And how did you get that?
You cancel the zeros.
Yeah. Every time you cancel a 0, it's like dividing by 10. That's dividing by 10, that's dividing by 100, that's by 1,000, that's 10,000, that's 100,000. Geez, I thought that was going to be a little harder. About 14 over 98. 7 will work. What else will work? 14? Does 14 go into 98?
Yes.
How many times? 1 7. All right, not that bad, is it?
No.
That's just a shorter way of figuring it out, right? I mean, just like you said with rule number 1, if you divide everything by 2, that's just going to be the longer way.
Yeah. The reason why when I try a number, I go to the next higher number. A lot of times, if you don't go high enough, you're going to have to do it in 2, maybe 3 steps. The higher number you go, it's usually doing it in 1. So that's what I'm trying to do. I mean, on all of these that are like technically, you could keep dividing this by 2 for quite a while. You'll get there. You'll get there. Yeah, Christmas is coming. So is New Year's and Easter. 4th of July, too, by the time you're done with that one. That's something else. But I mean, that, you know, it will work. Like a lot of times when I'll say 5, if 5 works, try 25. If 25 works, try 125. You know, you'll find out that it'll get you to the finished product quicker. All right, let's try something else here. How about this one?
Number 3.
All right, yeah, I want to know what you got to divide into it. I don't want the answer. 9. And we're going to get 1 over 3. Final answer. All right. Call a friend. All right, what can we reduce this one by?
64. By
64. David says, let's go right for all the money. This goes in here how many times? 2. So this is 2, 1 over 2. So this reduces to 1/2. Now, we didn't have to use 64. We could have used 8. We could have used what? 4. We could have used 2. We could use a lot of 2s. It would work, just a little more work though. How do you want to start out on that one? 5 immediately. 15. Does 15 go into 45? 1/3. Uh, 11 doesn't work here.
Nothing.
You can't
Are you
see.
sure?
11.
I left what?
No, never mind.
Nothing goes in.
Will 2 work?
No.
Will 3 work?
No.
Works here, not here. 4?
No.
5, we know it doesn't work because there's no zeros or 5s. 6,
No,
7,
no,
8,
no,
9,
no.
we're done. Well, if one works, we're right back. One works on all of them, but it still might not get you in simplest form. Straight out there. Okay, how about this one?
Negative 3.
I hear 3, I hear 5.
Negative 3.
Negative. 3. You want to divide this by 3?
No.
It's 5.
5. We'll divide this by 5, we'll divide this by 5, we'll get 3 over 1. Are we done?
No.
What do we got to do, David?
Divide 1 into 3.
And what do we get?
3.
There's your final answer.